Good evening, everyone, and welcome to Astronomy Toronto. I'm your host. My name is Randy Attwood, and I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada. Tonight is a special live 1-hour episode of Astronomy Toronto where we're going to be talking about the return of Comet Halley. So we all know we've been inundated with newspaper and radio reports that the comet is now visible from Earth. It's just barely a naked eye object visible in the sky in the evening. And tonight we're going to be looking at what comets are, we're going to be looking at who Edmund Halley was, and what we'll be able to see during this current 1985-1986 return of Comet Halley. We'll be inviting you to call us during the show, so when you see the phone number come up on your screen, that means that we're ready for you to give us a call, ask us anything you may have, any questions you may have about Comet Halley or amateur astronomy, because that's what we are. We're amateur astronomers getting ready to watch Comet Halley as it becomes more and more visible in our sky. I have two guests tonight to help me look at Comet Halley. First is on your left, Ian McGregor. Ian is an educator at the McLaughlin Planetarium here in Toronto. Thanks very much, Ian, for coming by.
You're welcome, Randy.
Ian will be the first to tell you that he's been inundated with requests for Comet Halley talks and slides and whatever, but thanks again for coming. On your right is Michael Watson. Michael is an amateur astronomer and also a member of the Royal Astronomical Society of Canada. Thanks, Michael.
Nice to be here.
Well, as I say, we're right in the middle. For the next 6 to 8 weeks, it'll be the best time to see Comet Halley from southern Ontario. That is the best time when the moon isn't in the sky. So we're talking about the 2 weeks between now and December 15th, and then 2 weeks in early January. So gentlemen, the fact that the comet is in the sky now, everyone's getting excited about it. What are amateur astronomers really gearing up to do? Ian?
Well, I think first of all, everyone wants to see it. It's been very frustrating over the last month or so, 5 weeks or so, with all the clouds that we've been having. And everyone's looking forward to seeing it, getting their first look at it, 76 years, and for most people, their first occasion to see it. People want to photograph it and see it through their binoculars, and it should be quite exciting. I saw it for the first time 2 nights ago.
Yeah, Michael and I were out the other night too, and Michael, we got a good look at it. We've all just had our really first good look at it. Describe what it looked like to the naked eye through binoculars and through a telescope, like this week.
Well, 2 nights ago, we went out about an hour east of Toronto near Port Hope to a nice dark site where you have to go. You have to get out of the city. And we just barely saw it with the naked eye, with the unaided eye, without any optical aid. It was a very faint, fuzzy patch, but in binoculars, it was surprisingly bright. And in binoculars, it appeared to be about the size of the full moon, really nice and bright, really quite sort of a fuzzy ball, elongated because the tail is now starting to show on the comet, and sort of a little bit centrally condensed, but definitely different than the stars because it is large and fuzzy.
Okay. What we're going to do for the next little while is look at some slides of different comets and talk a bit about what comets are, a bit of a background of who Edmund Halley was, and then we'll get into what we really expect to see during the next few months. If we get the first slide up, you'll see a picture of just a regular comet. This is a picture of Comet West, and Ian, this is a super comet in 1976.
Yes, it was classified as a great comet, in fact. Very bright. It was about second magnitude, in fact, in the astronomical scale that astronomers use. It has a nice bright nucleus, which is on the right side of the picture, and then the tail going off to the left. It was very beautiful in the second week of March of 1976. For most Ontario observers, we couldn't see it because it was cloudy. But a few of us did manage to get into out into dark areas, and also went out in the early morning, say about 3 or 4 o'clock in the morning, and were able to see the comet just before sunrise.
In the next slide is a picture of a comet which was visible in 1970, Comet Bennett. And this too was out of Comet Bennett in 1970, Comet West in 1976. These two comets, Michael, were really the only good, or as Ian said, they've been classified as great comets for the last 20 years.
Well, that's right. Normally, we have up to about, say, 3 bright comets in every decade, but we really haven't had any bright ones in the last little while. The interesting thing about these two comets, and the reason why most people may not remember seeing them, is that they were both morning objects. That is, they were visible in the morning sky before sunrise when people are generally in bed, rather than in the evening after sunset.
The next slide will show another comet which was very interesting because this was what they call a sun grazer. Ian, what does that mean?
Okay, there are a family of comets that we know about. There's at least 12 or 15 of them, which are called sun grazers. They are very big comets, and literally they graze the sun. They come very close to the sun within a matter of a few million kilometers of the sun's surface, and this means that the sun's energy and radiation is interacting with them very strongly. And what often happens with these sun grazing comets is that they're destroyed by the sun. They're broken up. Instead of being one nucleus to it, one basic body, they break up into several parts and disintegrate.
But that's not the case for Halley. It doesn't go really that close to the sun.
No, Halley doesn't get that close. In fact, it doesn't get inside the orbit of Mercury. It does get closer than Venus, but not inside the orbit of Mercury. And
in this slide of this comet, I can tell you that the name of this comet, the sun grazer, which was seen in 1965, is Ekia Seki. And these are new comets, never seen before, discovered by astronomers, even some amateur astronomers. And if you are an amateur astronomer or anyone, if you discover a new comet, you get it named after you. And we have a member of our organization in Ottawa who's discovered 4 comets, Rolf Meyer.
That's right.
And so if he's discovered the comets, you'll see they're named after him.
And David Levy as well is another person.
That's right.
In our society.
That's right. In the next slide, we have a drawing of a comet which was seen, Donati's comet, which was seen when, Ian?
This is the Great Comet of 1858. It's considered to be the brightest comet of the last 200 years. And this is a depiction of Donati's comet over London, England.
And you can see that the tail is the most spectacular part, isn't it?
Very much so. In fact, if you look at it very closely, you can see that there are 2 tails. There's one that's almost vertical, and then there's one that's sweeping off to the right. We find that many comets have more than one tail that we can see in the sky. Comet Bennett in 1970 seemed to have basically a single tail. Comet West in 76, though, had a number of tails we were able to see.
Some of these comets are really tremendous, Ian. This one is had a tail which stretched nearly right across the sky, didn't it?
This is another great comet, the Great Comet of 1843. It is the comet with the longest tail on record, 170 degrees. Now, if we realize that from horizon to horizon, that's 180 degrees, and this tail was 170. So it must have been a magnificent sight to skywatchers in 1843. In
the next slide, we have a diagram which shows the different parts of a comet. And Michael, if someone was to ask you, what is a comet made of? There's a pretty simple answer, isn't it? We do know what they're made of.
Well, we do pretty much. The best description of a comet is that it's a dirty snowball, and it consists of different kinds of ices, generally water ice, and dust and little pebbles and particles such as that. The nucleus of a comet, or the head of the comet, the very small part of the comet, is very small. It's only on the order of, say, somewhere between 5 and 50 kilometers in diameter, so it's very, very small, but it sports an enormous long tail. And in this diagram, we can see the nucleus, which is very small. As it gets close to the sun, the nucleus gives up gas, the ices vaporize, and it forms what we call the coma, which is the brightest part, a cloud of gas surrounding the nucleus, and then the tails sprout off, 2 tails. The plasma tail, which is basically a straight tail. It's ionized or charged particles which stream away from the sun, and then what is shown here as being sort of an orangey tail, and it actually does look slightly yellowish, and that is the dust, and those are the 2 basic kinds of tails in a comet. And the blue part there is an enormous hydrogen cloud that we now know, and it has recently been discovered, surrounds most comets.
Ian, what are we talking about with sizes? With Halley's nucleus, it's only on the order of a couple dozen kilometers.
In fact, it's even smaller than that. We're probably looking at an object maybe between 3 and 10 kilometers in diameter. And we might come along and say, well, what's all the fuss about an object that's so small, 3 to 10 kilometers? We can fit into downtown Toronto. But actually, as Michael was saying, when the comet gets close to the sun and it starts to break up, this coma that surrounds the nucleus can get very big. It could be perhaps 100,000 kilometers in diameter. And the hydrogen cloud could go perhaps as large as 1 million kilometers in diameter. The tail, which is basically empty space, could perhaps stretch for maybe 100 million kilometers, enormous distance.
This is an artist's conception here of what you might see if you were very close to the nucleus of a comet. And as we were saying, it is only when the nucleus gets close to the sun, gets warmed up so that the ices sublimate, go right from solid to a gas, release the dust particles, that all of the particles sweep off, form the coma and tail. And in that slide, you could see that on the sunlit side, which was the warmest side, that was where most of the debris was coming off.
Exactly.
There's another slide we have here, which is another artist's depiction of what you may see if you were standing right on the nucleus. And Michael, one thing that people may wonder is if a comet is losing all of this debris, then what about a comet like Comet Halley, which is going around the sun every 76 years for who knows thousands of years? Isn't there a certain point when all the material will be used up?
That's a good question, and the answer is yes, but it's a question of when that occurs. And it is generally thought, although we don't know all the answers about comets, there are a lot of things we don't know, but it is generally thought that every time the comet passes close to the sun, it loses about 1 meter of it from its surface, and so it's shrinking in diameter by about 1 meter per revolution. Well, if it's several kilometers in diameter, you can see that it will be several tens of thousands of years that it will last.
Now, a lot of these comets that are the brighter ones, say Comet Bennett, Comet West, they're actually comets which are coming in from the far reaches of the outer solar system for pretty well the first time. Is that not what we believe, Ian?
A lot of them are. In fact, a lot of the very bright comets, the great comets that we see, are comets that we've not seen before. And this is why they're sort of a surprise to us. We only discover them perhaps a few weeks before they're at their brightest. And it makes Halley a little bit different because we know it's going to come back.
We know it's going to come back, but also the comets which are coming in towards the sun for the first time. It's really the first time that their gases have been melted, and so they must have a lot more material to release, I suppose.
The great comet Kohoutek in 1973 was thought by many people to have been a comet possibly coming into the inner solar system for the first time.
Well, the comet we were talking about now, of course, is Comet Halley, and it was named after a gentleman, Edmund Halley, a British astronomer, inventor, scientist, who we have a picture of. And Ian, you've done a lot of reading about Edmund Halley. Who was he?
Edmund Halley was a very fascinating individual. Quite apart from all of his associations with his comet, he was a very great man in his own right. He was born in London, England in 1656. When he was 19 years old, he published his first paper on a scientific subject. When he was 20 years old, he sailed into the southern hemisphere and charted the southern skies. When he was 26, he observed a great comet in the year 1682, which actually was his comet, if you like, or later became associated with him. He was important in the areas of geography, magnetism. He built a deep-sea diving bell, the very first deep-sea diving bell that was built. He was known as the Tycho Brahe of the southern sky because of his mapping of the southern stars and constellations. He was a good friend of Sir Isaac Newton, one of the greatest astronomers who's ever lived, and an astronomer of the 17th century. And in fact, he did a lot to get Newton to publish his great work on mathematics and gravity, the Principia Mathematica. And in fact, Halley went as far as to actually pay for that particular book to be published.
Michael, why is Comet Halley named after Edmund Halley?
At the time that he lived in the 1600s and the 1700s, it was not known with certainty whether comets were permanent members of the solar system or whether they simply came through on straight lines and passed straight out of the solar system. It was generally thought at that time that probably comets had orbits and returned to the vicinity of the sun and the Earth time and time again, but that hadn't been established with certainty. Halley used a new invention, which had been invented by Isaac Newton, called fluxions back then, and we now know it as calculus, to investigate the orbits of several comets which had been studied in the past and for which positions had been known. And he noted that there seemed to be 3 comets in particular that seemed to have the same orbital characteristics. He noted that those comets seemed to be 75 years apart in their observations, and he came to the rather bold conclusion at that time that they were in fact one and the same comet returning time and time again. And he made the prediction that this comet again would return in the year 1758. Although he died several years before that year, in fact his prediction came true, and on Christmas Day 1758 the comet was rediscovered, and since that time it has been called Comet Halley.
Comet Halley is in a very interesting orbit. It goes, as Ian said, close to the sun, not as close as Mercury does, and its orbit goes out beyond Neptune, even above the top of your TV set is how far Comet Halley goes. And Ian, it's a 76-year orbit. Why does Comet Halley have such a short orbit astronomically speaking, where all the other comets are in very large orbits. How did Comet Halley get into this orbit? Do we know?
Okay, we perhaps had to backtrack and think about where comets come from, and we think that surrounding the entire solar system is an enormous cloud of comets, perhaps millions or billions of them. And every so often, one of these objects gets pushed or pulled into the inner solar system, and then more or less it starts a death ride, because as soon as it starts coming into the inner solar system, it starts to disintegrate because of the sun, and eventually it's going to be used up. Now, quite often these comets, as they come in, encounter, say, a giant planet like Jupiter, and Jupiter's gravitational attraction changes the comet's orbit. So instead of having an orbit of maybe hundreds of years or thousands of years, which probably was originally Comet Halley's period, gradually it's reduced, so now it's 76 years. And I would imagine over the course of thousands of years into the future, Comet Halley's period will gradually decrease. There are, for example, comets on record that have periods of only a few years. Comet Encke, for one. We see it about every 3.3 years.
But it's been going around the sun for so long that it never gets bright enough to see with the naked eye, Comet Encke.
Yeah, it's used up. It's all of its volatiles, as it's called. Ices and such are gone.
In the next slide, we'll see a close-up of what Halley's orbit looks like. And the interesting thing about Halley's orbit is the fact that it's not in the same plane as the other orbits in the solar system. It's tilted. It's about 17 degrees, I believe. Is that?
18 degrees.
18 degrees. And this is at the point which will be February 11th, when Halley is reaching what's called perihelion. And you'll notice that at the point where the comet, Halley's comet, is closest to the sun on February 11th, look where the Earth is. Somehow we're just not in the right spot to see the comet when it's at its brightest point, because we'll have to look right at the sun to see the comet. And I guess, Ian, that is the main reason that this apparition, this time Halley's comet comes by, we're not going to get a very good show.
That's right. Actually, the date of closest approach is February 9th. And because the comet's going to be on the far side of the sun to us when the comet's closest to the sun, this means the only time we can really observe it is when the comet is coming in towards the sun, and then after it is moving away from the sun. And if somehow we could sort of turn off the main power switch for the sun, then we'd actually be able to see Comet Halley, although I guess we'd also lose the light from it because we're seeing it by reflected sunlight.
One thing that's always been interesting about comets is the fact that they somehow have got the tradition or the name that when a comet comes by, there's going to be trouble. And the next slide shows a depiction from the Bayeux Tapestry, which sort of was unfortunate for one person. Ian, could you tell us about this?
Okay, this is a depiction of the return of Comet Halley in 1066 AD. And in the year 1066 AD, there was the very famous Battle of Hastings. Now, in the spring of that year, Comet Halley was visible in the sky, and it was in October of that year that the Battle of Hastings took place. That was when William of Normandy invaded England and defeated Harold of Wessex, and after that, England became a Norman country. And the Bayeux Tapestry was made over the next 10 years after the Battle of Hastings. It was an enormous tapestry. It stretched about 100 meters, I think, or so. And what it basically is depicting is the comet up in the sky. On the right, we have King Harold and one of his servants or advisors. And over to the left, we see some people looking up into the sky. And the words that are beside the comet is that they admire the comet. They admire the star. And this was interpreted as meaning bad news for Harold. Usually comets were associated with bad news, disasters, catastrophes, and this is sort of nil omen for King Harold. And sure enough, I suppose it was. He lost the Battle of Hastings and lost England.
The next slide will show what we were talking about a bit earlier, the date in 1759, when Comet Halley was seen on Christmas Day. And I guess, Michael, this was really a turning point for astronomy, especially cometary astronomy, to actually see that comets are in orbits. And I believe what Halley said was, if my predictions are true, because as you say, he didn't live to see this, he wanted that the comet be named or let it be known that an Englishman was the one to predict it.
Well, that's right. That was one of his fondest wishes, and of course something that he said before he died. Of course, when he made his prediction, he knew that the chances of him seeing it a second time were very slim, and because of the fact that it's a 76-year orbit, unless you see it one time, for example, when you're very young in your early years, you won't see it a second time, and he knew that that would be the case for him.
The latest return of Halley was in 1910, and I'm sure we have many viewers tonight who remember seeing Comet Halley in, I believe it was May, was the best month in 1910 to see it. And there are a lot of people who are looking forward to seeing it for the second time. I believe there are even some small clubs being formed of people who have seen Comet Halley in 1910 and are looking forward to see it now. Maybe some people already have seen it twice.
No, quite possibly.
I know Dr. Helen Hogg of the Royal Astronomical Society of Canada, past president, who recently was married, and we'd like to congratulate her on her recent marriage. She saw it in 1910. Maybe she has seen it already. We have a drawing of what Halley's comet looked like in 1910. There aren't that many photographs, but 1910 was the first time that Comet Halley was really photographed. And it was a very good apparition. A lot of people saw it. It was very bright. Why, Michael, was it so much brighter back in 1910, and we don't expect it to be as bright this time?
Randy, a comet, when it returns, can have any kind of appearance, and it all depends on what we call the celestial geometry. And what that means is the relative positions of the Sun and the comet and the Earth. And as we saw in the diagram of the return this time, the Earth and the comet never get very close together. They're on opposite sides of the Sun when the comet is at its brightest. In 1910, when the comet was at its brightest, the Earth happened to be in that portion of its orbit when it was very close. And in fact, on May 18th, 1910, the Earth passed right through the tail of Comet Halley, which is something that simply cannot possibly happen at this appearance.
And I believe that's where the story's from, that astronomers with telescopes were able to detect cyanide gas, Ian, in the tail.
And cyanogen gas. Just a couple of months before the comet was supposed to get closest to the Earth, they picked up cyanogen gas, which is a poisonous gas, and because it was thought the Earth was going to pass through the Earth's tail on the evening of May 18th, 19th, a lot of people got all excited about it. They thought, oh no, it's going to be the end of the world. There were miners, for example, who refused to go into the pits because they wanted to be on the surface when the end of the world came. There were people who went ahead and plugged up their windows and their doors so that the gas wouldn't get into their homes. And there was a lot of fear about that. And I guess the other half of that was not only the gas. Some people thought that maybe the comet might change its orbit suddenly and also collide with the Earth. So there was sort of a lot of fear in that area. People went ahead and were selling gas masks. There were famous comet pills that were sold for $1 each. Now, I imagine $1, considering what's happened over the last 76 years, those pills must have been fairly expensive.
And they worked.
Well, that's right.
They worked. No one died as a result of it.
No one died. The Earth was saved,
So
and everything was okay with the world.
$1 well spent.
Exactly.
In the next slide, we have an actual photograph of Halley back in 1910. This was really the first appearance of Halley where photography was being used. But it really, the amount of detailed investigation that's going to take place next year, astronomers all around the world, spacecraft heading towards the comet, telescopes in orbit. It's an incredible setup for this time. Everyone is ready, but the thing is we've had 76 years to get ready. Isn't that right?
Well, it is, and certainly many forms of astronomy and astronomical observation were really in rudimentary form back in 1910, and we really are ready this time. Unfortunately, as we've said, for North Americans it won't be a good show, but for people in the southern hemisphere, or perhaps even closer to the equator in the Caribbean, in the month of April next year, we're all going to get a really spectacular show.
The comet was recovered by using one of the largest telescopes in the world in 1982. It just looked like a little speck in a photograph, and we have a slide of that. Telescopes have been actually following the comet since October 1982, and that's the comet, that little star-like object with the circle around it. And as I say, we've been following it as it's been coming in, but now it's at a brightness where binoculars in a dark sky, you'll be able to go out and take a look at it and see what it looks like. Again, this is a live show, Astronomy Toronto. At this point, we'd like to invite any viewers tonight to give us a call. You should see the phone number come up on your screen in a minute. The next part of the show, we're going to be talking about where to look to see the comet, and a bit more of information about what is planned and how basically the best views of the comet are not going to be from the northern hemisphere, but from the southern hemisphere. But we'd invite you to give us a call, give us your comments about the whole comet craze. I think a lot of us would like to be telescope manufacturers at this point in time, binocular manufacturers anyway, because I think a lot of people are going to get telescopes for Christmas. What about the whole comet craze? The interesting thing is that not only is astronomy and comets are becoming popular, but even amateur astronomy. Ian, what's going on at the planetarium?
Well, we're very busy at the planetarium. There are a couple of us on the staff who are spending actually most of our time dealing with the public and preparing astronomical materials and talking with teachers and school boards and whole thing as far as the comet is concerned. So we're very, very busy from it. And I think one of the things that's going to happen from this return of Comet Halley is perhaps a much higher profile for astronomy in general, because a lot of people are getting excited by the subject. They want to learn more about it. They want to take courses. They're starting to look at the sky. And perhaps we're having people looking at the sky who've never really looked at it before. It's surprising, for example, how many people do not really realize that the Earth rotates. You can come along and have people fill out a questionnaire and say, does the Earth rotate? Oh, yes, it does. But when it comes to looking at the sky, we have to realize that not only does the sun appear to move across the sky during the day, but the stars also appear to move across the sky at night. And that affects the comet's position. And that's something we'll be talking about, I imagine, a little bit later on.
Yeah, maybe we can talk a little bit about that now. The people that I have talked to, I really think because comets have tails, and I think I have a basic picture of a comet here. Because comets have tails, and you see that the tail, it looks like there's movement, it looks like there's motion, but the tail is not because the comet is racing across the sky. We've talked about why the tail is there, because of the action of the sun. But a lot of people will look at that and figure that it's because of the motion across the sky, therefore the comet must be racing, and I've got to go out at a certain time of the night and look up and see the fireworks go by, and then, bang, I've seen Comet Halley. And that is nothing like what you really see.
Yeah, really, after the sky has got dark, we go out and look up in the sky, and there's the comet. And the comet's up there for many hours. It's not streaking across, as many people refer to them.
One of the points that can be made is that the comet can be seen someplace in the sky for many weeks and, in fact, many months on end. And from night to night, the comet moves through the sky with respect to the background stars about 1 moon diameter, 1 full moon diameter. So it doesn't move all that quickly from night to night.
Good evening. Welcome to Astronomy Toronto.
Yeah.
Hello.
Hello?
Yeah, could you speak up and...
Yeah.
What's your question?
Where will I be able to see the comet?
Where? You mean where in the sky?
Yeah.
Okay, well, I think we're just about ready to get to that. Michael, why don't you try?
All right, maybe we'll do it this way. There's a certain period of time, and it's a 2-week period of time where the comet will best be seen. And it's a period of time between December 29th and January the 11th. Now, the reason why there are these cutoff dates is because between those dates, the moon will not be in the sky. And if you look on any clear night on those dates, get a nice low western horizon where the sun sets, wait till the sun goes down and the sky starts to get dark, and then look toward the southwest. And then using binoculars, look maybe about 30 degrees up, and to give you an idea what that is, from the horizon to the zenith is 90 degrees. So about, say, a third of the way from the horizon to the zenith, the overhead point, scan back and forth with binoculars, and you'll see a fuzzy little patch, possibly with a tail, and that'll be the comet. Now, from night to night, the comet will get closer to the horizon every night, about 2 full moon diameters by that time. So it's in the southwest, after sunset, in the deepening twilight, about a third of the way up toward the zenith, and use binoculars. That's the way to find the comet.
Okay?
Thank you very much.
Thank you. That's another thing we've been stressing about the fact that the light pollution from major cities is just going to make it impossible for a lot of people to see this comet. And really, 1910 was the last time that people in city centers will see the comet, unless it's an incredibly bright apparition many centuries down the road. Ian, when we're telling people about where to look in the sky, it has to be very difficult. It is not easy to express where to look, and how can you tell someone exactly where to look? It's difficult. What would you say to someone who really wants to see it, is willing to travel out of the city with binoculars? I mean, what would be your best advice for them?
Okay, well, probably the first difficulty that a lot of people have is actually even knowing compass directions. Perhaps from where their home is, they know where west is located or where south is located, but if they leave the city, go out in the countryside where it's dark, they often do not know where exactly west or north are located. I suppose the best thing for them to do there is either have a compass with them, so they get the rough idea where north is, or else if they're somewhat familiar with the sky, look for the Big Dipper, and then try and find the North Star. And then from there they should be able to find west and south. And hopefully they'll look over into the southwest and try and be able to spot the object.
Good evening. Thanks for calling. Where are you calling from, and what is your question?
I'm calling from Toronto, and when would be the best time to see Halley's Comet? As like, when, at what time and what day? In November.
Okay, you mean right now?
Yes.
All right, right now. Like if it was clear tonight, where would you look?
Mm-hmm.
Okay, Michael?
All right, well, we'll try to handle that. I mentioned earlier that the best period of time is between the 29th of December and January the 11th, but you can also see it right now because there's no moon in the sky for about another 10 days. And the way to do it, and right now, because it is so faint, you must get out of the city. You have to get out of the city to get away from the light pollution. Get out into a dark location, face due south, and again, you can use a compass, as Ian was saying, face due south, and then look up about 60 degrees, or about, say, 2/3 of the way from the horizon to the zenith. And if you can possibly get a star map, you'll see that there are 4 bright stars in a square called the Square of Pegasus. And if you can find those stars, and then using binoculars, just sweep along the sort of from east to west, about 60 degrees up in the sky, facing almost due south. After sunset, you'll see the comet, and again, it's going to be sort of a fuzzy, hazy patch of light.
And it's just below the Great Square.
Just below it, that's right.
Okay? Good luck.
Thank you.
All right. An important thing is if you can get your hands on a star chart or anything that's going to give you an idea of the position of the comet. And there are star charts with or books about Comet Halley available with very clearly written. One of the better ones I've seen is this particular one. It's called Halley's Comet, and it's by Francis Reddy. And the interesting thing about it is it has star charts in it, anything that you'd really want to see the comet clearly. But the main thing is that you get outside because, as Michael said, with the moon in the sky, when the full moon is in the sky, it's like, even if you're out in the country, it's like you're in Toronto because the moon is adding to the brightness, right? And
That's
you
right.
just can't see the comet at all. Good evening. Thanks for calling. And where are you calling from?
I'm calling from Toronto.
Mm-hmm.
Okay, would I be able to see the comet in the very, very early morning at before sunrise?
Before sunrise, like this week?
Any time between the 1st and the 15th is, when the comet will be here.
Right. Okay, so you're talking about right early for sunrise. Probably by that point in time, the comet will have set. Right now, just as it gets dark, say around dinner time, the comet is nearly due south, more or less due south. During the evening, up until the 6 hours from 6 o'clock all the way to midnight, the Earth is rotating, so we're rotating out of the way. The comet appears to be setting in the west. So just like the sun moving from noon to sunset in 6 hours, the comet will move to comet set by around midnight. So for most of the night, Comet Halley is not visible. It's nicely placed for us where we can see the comet in the early evening. Okay?
Okay, thank you very much.
All right, you're welcome. Bye-bye.
Bye.
Good evening. Thanks for calling, and where are you calling from?
I'm calling from Toronto. I was interested in the fact that Halley's Comet's right now going toward the sun, but supposedly around March, April, or May, it's going to come back around this way again, and it'll be a better view of the Halley's Comet than we have now.
Right.
Where, in relationship, have they found in relationship to the Earth where the best ways of looking at it then will be, and as far as picture taking and things like that?
Right. Yes, we really have, and Michael will tell you that we're all going to be heading that way.
Well, that's right. In answer to your question, the comet does reemerge from behind the sun, and we can see it starting in March and then into April. The problem with it, though, and this relates back to this tilted orbit that we were talking about, is that the comet moves very quickly into the southern sky. And as a result of that, it will be almost completely invisible from Canada after February. So that when it gets to its brightest time, and that's in the first 2 weeks of April 1986, it will be almost completely invisible from here. As a result, what you have to do is you have to go into the southern hemisphere, or at least closer to the equator. For example, if you travel to the Caribbean, or as we are doing, Randy is going to the Galapagos Islands, and Ian and I are going to the center of Australia. Those are the best places to see the comet, and we think that we'll see it extremely well from the southerly latitudes. But you have to go south to see it at its best time.
Okay, in relation to other stars right now, though, on its trip past us this time, if you're going to try to take a picture of it, you won't see much more than just what a regular star would look like, except it'd be fuzzy and it'd be moving, right?
Well, it'll be larger than a star. If you want to take a photograph, and you can try to do that with a simple 35mm camera setup by just taking a camera, putting it on a tripod, using fast film, and taking exposures, say, on the order of half a second all the way up to, say, 1 minute or 2 minutes. You can certainly do that, and you'll see the stars as little pinpoints, but the comet will be fuzzy, and it will appear fairly large. So it has a positive sort of large diameter as compared with the stars, which always appear to be pinpoints. So it has a definite different aspect than does a star, and it appears to be quite different.
Okay, thank you.
Okay, you're welcome. One aspect of this trip, Comet Halley, around the sun in 1986 is the fact that a lot of books are out there, and I brought just a few of the better books that if you want to read about the comet, we would suggest that you look at these books. One is called The Comet Book, a really excellent guide to comets in general. I really enjoyed this book. It's well written, and it gives you a good rundown of what to expect to see with Comet Halley. There are going to be a lot of official things going on with this comet, and you can buy the official Comet Book. This is the official Comet Book by Brian Harper, which is also a very good book. This magazine, called Astronomy, is a monthly magazine. It's an American magazine, but you can get it at a lot of magazine stores, and they're going to have monthly updates about the comet and what you'll be able to see. And if you're getting into astronomy, this is a very good magazine to pick up. Finally, for amateur astronomers, any aspiring amateur astronomers out there, there's a book published by Firefly, an equinox guide to amateur astronomy called Night Watch by Terence Dickinson. This is a wonderful book. For any amateur astronomers out there, a great Christmas book is Night Watch. And the author of Night Watch is Terence Dickinson. He writes a weekly column in the Toronto Star, the Saturday Star, called The Universe, and in that column he will be giving weekly updates all about the comet and what is going on in Toronto. And Terry's on the phone right now, and we're going to ask him a few questions. Good evening, Terry.
Good evening.
How is it out in Kingston tonight?
Well, this area, I think, is clouded out, as is all of this part of North America tonight. I think Halley's Comet is not possible to see from anywhere, certainly in the viewing area, I would say.
Terry, you've been watching the comet ever since it came into view in early September. For the last couple of months, what are some of the things you've been seeing?
I first saw the comet on the morning of September the 13th, and it was extremely faint, very difficult to see at that time, magnitude 13.7, which was just at the threshold of a 10-inch telescope for a diffuse object. At that time, it just looked like a smudge, and it hasn't changed from that appearance for about 14 different opportunities I've had to observe it between then and now, with increasingly smaller telescopes until now it's visible to the unaided eye from dark skies in a rural location. And it's only been this last viewing opportunity on December the 3rd that the comet has appeared as anything but a circular, diffuse, smudgy patch. It actually, to me, appeared to have an elongation on the left, the eastward side, which is the indication that we're beginning now to see a tail, or at least a V shaped object instead of simply a diffuse smudge.
So does that mean that Halley hasn't had a tail up until December 3rd?
No, I think I think at one time it probably didn't, way back in September, but I'm sure in October and November, if the alignment had been right, we would have been able to see a tail telescopically. But the alignment, I think, was such that we were viewing the comet practically head-on, and the tail was sticking out behind it and was blocked by the part of the coma, or the region near the actual solid body of the comet, that it had that circular appearance in that we were looking, in effect, straight down the tail of the comet, and it was being blocked by the brighter front part of it.
What the fact that we're not going to be able to see the comet from the city very well, and a lot of astronomers I know have been wondering about this. What if Halley just isn't seen by a lot of people? Is that going to be bad news for astronomers?
Well, I think that people like you and Ian and Michael have done a terrific job in informing the public, anybody who is interested, of the problems about viewing the comet from the city. And I think a lot of people that I have been in contact with lately are now prepared for the fact that it is very difficult to see from the city, and that it is necessary to get out of the city and have your binoculars with you in order to get a reasonable chance at seeing it. I think the expectations are gradually being eliminated, that you can step outside the house and get your hat knocked off by Halley when it comes whizzing by. I think this view was widespread, but in the last few months there has been enough, I think, a great deal, but I think enough, of the correct information getting out. So I think at this point that anybody who wants to see it knows what has to be done if they want to do it on their own, or will take the opportunity for a public observing session, which I understand you folks are going to organize sometime in January.
Right. We'll be talking about that later, but yeah, we definitely are going to be setting up telescopes for people to get their own look at Comet Halley.
I should tell you, Randy, that in Winnipeg, they had an outdoor session in November that was well publicized, and 4,000 people showed up to take a look through telescopes at Halley. So the interest is tremendous, and I'm sure there's going to be a terrific public service when you do this. But in the meantime, binoculars and getting out of the city really is the only way to have a look at it.
Terry, it's Michael. That last comment you made leads naturally to another question. It's a question that we've all been asked, and it's this. What do you say to people who insist that what they want to do is they want to buy a telescope to see it? They're not interested in amateur astronomy generally, but they just want to see the comet, and they want to buy a telescope instead of binoculars. How do you respond to them?
Well, my response is that that's probably not the way to go, in that binoculars do such a great job. Now, I had 8 people here at my house who were viewing the comet on Tuesday evening, and they were astonished. Now, all of these people were non-amateur astronomers, but interested in seeing Halley. And I had 2 pairs of binoculars, a 5-inch refractor, and a 10-inch Schmidt-Cassegrain telescope. My complete arsenal was outside. And after people had a look through the binoculars and the 2 big telescopes, they were astonished at how the binoculars showed the comet essentially the same way as the big scopes did. It was just brighter in the big scopes, but there was no more detail because we're looking at this diffuse ball of vapors. And that being the case, there really is no reason at all to get a telescope to see Halley when binoculars will do it, and binoculars have so many other uses. So I am a strong advocate of going the binocular route and forgetting the telescopes, unless, of course, you already have one.
Yeah, I think that's something that we've all been trying to impress on people, and I think we hope that the message has been getting through.
I think it has. Now, there are a lot of telescopes being sold with the name Halley attached to them, or with advertising suggesting that this is the way to view it. And I guess that is a way to sell telescopes, but those of us who actually use the equipment, and even people who casually have the opportunity to compare realize it's just not the case. It's not necessary. Binoculars do a terrific job.
Okay, we'll have to let you go, Terry. Thanks very much.
Okay.
And we'll all look forward to reading about Halley in your column in the Saturday Star.
Okay. Well, I just wish I lived close enough to get your show on cable, because then I'd be enjoying it with the rest of the audience.
Well, maybe we'll get you on the set someday.
Okay.
Thanks, Terry.
Bye,
Bye-bye.
Terry.
Good evening. Thanks for calling Astronomy Toronto.
Yes, thank you very much. I wonder if you could explain to me in layman terms, because I haven't even gone so far as to check these type of things out with telescopes or anything else. Could you tell me how fast Halley's Comet travels in miles per hour, approximately?
Ooh.
Well, when it's closest to the sun, it's moving about 100 kilometers per second. That's when it's closest to the sun. So I'll have to go ahead and do a calculation to figure that out in the miles per hour.
Okay,
But pretty
again,
fast.
another question I had, again, in layman terms without getting too technical. Everybody is so used to seeing everything traveling around the sun circularly. Halley's Comet, when you show the diagram, has an oval type of orbit where it seems to come from deep space around a sharp curve around the sun. And what causes it to make its orbit an oval orbiter? Again, like I say, in layman terms, what causes it to take an orbit of that shape?
Well, we believe that when the comet came in on its first time in towards the sun, it would have done what all other comets do, going around the sun and then back out to the far reaches of interstellar space. But when Halley came in, it must have traveled close to a big planet, say like Jupiter. So just like as spacecraft are sent close to planets to use the slingshot effect, the comet must have been slowed down, its velocity changed, its direction changed, so that it was more or less slowed down enough to be captured by the sun in a smaller orbit. Now, it might have taken one or two or several, say, Halley-Jupiter or Halley-Saturn interactions, so that Halley is in an elliptical orbit. But there are several comets that have had that happen. But not many comets are what they call the short period comets which have time to go around the sun in less than 100 years.
Okay, well, that answers my question. Thank you very much. Very interesting show.
Great, thank you.
Righto.
Bye-bye.
Bye-bye.
Good evening. Thanks for calling Astronomy Toronto.
I'm from Don Mills, and this may sound kind of odd, but I was wondering what the proper way to say Halley's Comet is.
Good question.
What a great question.
Yeah, that's great.
You must have read my script. Michael's the Halley, Holly, Hooley expert.
I suppose we can say it any way we want, but if we want to be correct, there are three possible ways to pronounce the name of the comet. There is one that is almost certainly wrong, and that is Halley. That is absolutely, for certain, dead wrong. Another way of pronouncing it, and this is a possibility, is Halley. It is a possibility that he pronounced his name that way in his lifetime. But most astronomers now believe, and it's really accepted beyond question now, that the proper pronunciation is Halley. So you can call it Halley's Comet or Comet Halley, but don't call it Halley, whatever you do. That's just plain wrong.
And that, of course, is from Bill Haley and the Comets of the Rock and Roll.
Well, that's right. I mean, it's surprising that is the case, because the comet is pronounced Halley's only in North America, and it only has been for the last 25 years or so.
We should realize, too, that Edmund Halley spelled his own name 13 different ways. And on his on the will that he wrote before he died, he spelled his surname with an O. And so it sort of confuses the whole thing. And of course, we're coming from a time when spelling was not very important. People sort of spelled their name the way they sort of wanted to spell it at the time. Today, it's much more important. If you spell your name the wrong way, the government might be after you, or who knows what might happen. That's the explanation.
You're still on hold.
Okay, continue.
Okay, so that's an explanation there.
Okay, thanks very much. We have another slide which I'd like to bring up, which is a photograph that Ian took. And Ian, the interesting thing about it is that a lot of amateur astronomers are going to be taking photographs themselves of the comet. Maybe you could tell us a bit about this photo.
Okay, this is a photograph that I took on March 7th, 1976, of Comet West. It was taken very early in the morning, just before sunrise. I would say, I think it was about 5 o'clock or 5:30 in the morning. In this picture, we have the sunrise glow at the bottom of the picture and some clouds. We have Comet West, and then just above and to the right of Comet West is one of the bright stars in the constellation of Pegasus. But this photograph was taken using an ordinary 35mm camera, a 55mm lens on the camera. The camera was sitting on a tripod. I was using a cable release film, slide film, 160 ASA, about 200 ASA now, and about a 25-second time exposure. And it was a very easily spotted sight in the sky.
Yeah, that was rather brighter than Halley will be.
Much brighter.
But the main thing about photography is a fast film ASA 200, 400, 1000, and get away, again, we can't
Away from
stress
city
it,
lights.
away from the city lights. Okay. Michael, a lot of people are going south, and exactly where are they going, and how many people are we talking about?
Well, they're going all over the place in the southern hemisphere. There are a lot of people going to South America, Chile, and Peru. There are people going to Africa. There are people going to the Caribbean, and a huge contingent of people going to Australia and New Zealand. The numbers that I've heard are, well, Alice Springs in the center of Australia has a population of 20,000, and I have heard numbers of 10 to 15,000 astronomers going to jam into Alice Springs during the first 2 weeks of April.
Actually, my figures I've got are even higher than that. The estimate that the Alice Springs Astronomical Society is using is 50,000 people in a 3-week period.
It's unbelievable.
And apparently there's a report that the Japanese Astronomical Society is planning to have a tent camp for 80,000 people on the outskirts of Alice Springs.
Now, the rule is it's great to be south of the equator, but a lot of pocketbooks aren't going to allow that. Would it be safe to say that if someone wants to get a closer look by, say, going to southern Florida or Mexico or the Caribbean, it would be worth their while to get as far south as possible?
Absolutely. Certainly if you go to Texas or Mexico or even southern Florida, the comet will be above the horizon and substantially above the horizon in the midnight time period during the first couple of weeks of April. And certainly it's a cheap flight down to Florida. And you know, if you want to drive down as well, you can certainly get a very nice view.
But in Toronto, you're out of luck.
Almost
Yeah, forget
completely.
about it.
Yeah.
And avoid the moon.
Keep away from that moon. Good evening. Thanks for calling. Where are you calling from?
Toronto.
All right. What's your question?
Have there been any movies on the comet?
Movies about the comet. There have been a lot of things on TV. I believe PBS will be having a show in January, I think the Nova program, January 21st. Apart from that, you're looking at one of the only Comet Halley TV shows, right, that I know of. I don't know of anything else that's going to be on.
There's, I've heard about an IMAX movie on Comet Halley, which may be in the works. There's some difficulty in photographing the comet, certainly with movie film, but there may be an IMAX movie coming out on Comet Halley, and so you can look for that sometime in 1986, I think.
Okay, thank you.
Okay, bye.
We've been talking about some spacecraft that are on the way to Halley. One is called Giotto, named after an Italian artist who depicted Halley in one of his paintings. It's a European spacecraft that's going to be traveling by the comet on March 13th. There is some talk that there are cameras on the spacecraft. It's going to travel within a few thousand or even 500 kilometers of the nucleus. The comet photographs are going to be coming back very quickly because as the spacecraft travels right through the coma, a lot of scientists believe it might be a suicide mission. But there is some thought that when these pictures come back out of Europe, it may be put on television live. We'll have to wait for that March 13th. Good evening. Thanks for phoning.
I already answered your question.
Okay, thank you. Thanks for phoning.
Hello. Yes, my name is Jeff Leitner.
Hi, Jeff.
Hi. And I can understand how the man felt because my last name's Leitner and many people pronounce it Littner or Leitner.
Have you discovered a comet by any chance?
No, but if I did, it would be Leitner.
Leitner's comet, all
Okay,
right.
can we have your
Comet
question
Leitner.
quickly?
Yes. What position will Comet Halley be in the year 2062? Will it be further away from the sun so we could see it better?
Quickly?
It's a better return of Comet Halley than this one. This is the most unfavorable return of Comet Halley in 1,000 years. The return in 2061, 2062 will be much more favorable. I think that Comet Halley's closest approach to the Earth will be about 20 million kilometers. For this return, it's 63 million. And then the big return that I would like to say everyone's waiting for is the one in 2134, 2 returns from now, when Comet Halley is supposed to get within 5 million kilometers of the Earth. and it will be very, very bright.
I've got a question for our caller. Are you planning to be around in 2061 to see it?
Well, I hope so.
I hope you are too.
Good luck.
Thanks
Good luck.
very much. You may not be around for the 152 years.
Might miss that one.
For anyone who wants to see Comet Halley, the Royal Astronomical Society of Canada will be setting up telescopes during the first week in January, between January 6th and 11th. And if you got a pencil, you can write down this phone number. This is an astronomical hotline that's at the McLaughlin Planetarium, which Ian updates every week with events about the sky and whatever. The number is 978-5399. That's the astronomical hotline. On that, during the first week in January, we will have information about the comet. Ian will be updating about information about the comet all the time, but we will be saying where we will be setting up telescopes around the city during that week. So if you want to come out and see the comet at that time, please do. I'm afraid we've run out of time. If callers on the line, please hold. We'll talk to you after we go off the air. The next program of Astronomy Toronto will also be a very special live program. On January 25th, the Voyager spacecraft will be flying by the planet Uranus. And pictures will be coming back of Uranus, its rings, its moons, and it's going to be very exciting. We'll be having pictures of that encounter for you on January 25th. Again, the astronomical hotline, phone at 978-5399. My guest, Ian, Michael, thanks very much. Bye from Astronomy Toronto.